You might be thinking, we're supposed to be talking about the future. Why are we talking about cloud computing? Cloud computing is something I hear about all the time. But cloud computing is a movement and a sort of a redesign of some fundamental interactions on the internet that may have big consequences for our interactions on the internet in the future. What is cloud computing? So cloud computing is really sort of a rebranding of an old idea of distributed computing. So, the idea is that I connect to this all-powerful cloud, and the cloud is where I sort of provides me with my email. The cloud might also deliver music to my device. The cloud can host web pages. And the idea is that inside, what is the cloud? Well, the cloud's just a bunch of machines, right? A bunch of machines in various data centers around the world. Maybe there's one data center there and another data center here. And so there's no mystery, there's no magic to the cloud. The cloud is distributed computing. The cloud is just a bunch of machines in a room somewhere. So if you want to see the cloud, Google the pictures of Google's data centers, and you can see, thousands and thousands of machines, and that's part of the cloud in Google Cloud Computing. So again, there's no magic or mystery here, but the term cloud computing and some of the goals of cloud computing are really supposed to mean that the cloud is this all-powerful, reliable entity. So the cloud is never down. The cloud will always have time to process my data. The cloud will always have somewhere to store my data. And so you try to sort of tear away some of the individual machines you might see in distributed computing, and I can back an entire interface, I can back an entire service with this amorphous set of computing resources that will always be available and will always be ready to serve my needs. So that's sort of the goal of cloud computing. Now, what's interesting about cloud computing from my perspective is that in the early days of computing, computers were these big, expensive devices. They were locked inside a room somewhere, and there were very few people that had access to them. So one of the reasons that Bill Gates got started was that he had access to a computer. And back when he was growing up, that was actually really weird. You didn't have a computer at home. Bill Gates got special permission to go use this computer close to where he lived, and he was actually able to program that computer frequently, and so he got a lot of practice. He was very good at programming in an age where that was very difficult to do because most people didn't have a computer to use. Then there was this whole movement. So you start in the 60s, 70s, computers are these expensive things that very few people have access to. And the vision of how we were going to provide people access to computers was this idea that was known as dumb terminals. So I would not have a computer at home. What I would have is essentially just a display. All I would have is a monitor, and that monitor would be connected to some powerful computer in a closet somewhere that was very carefully maintained by a team of experts, and that's how I would get access to computers. Now, at some point, what happened is the transistors kept getting more powerful and smaller, and eventually personal computer, this whole movement, which we take for granted, but it really was a huge change in how people thought about computing. You can actually buy your own computer. Computer clubs got started, and there was a huge movement towards people having really powerful computers at home. So your parents, me, a lot of people own a PC, a desktop computer. That computer is thousands, if not millions of times more powerful than those old servers that we were going to use to run these dumb terminals. So computers got really powerful and then got cheap. So a bunch of people bought one. So that was sort of the contribution of the personal computing movement. Now it's sort of interesting because now we're sort of headed back in time in a way with this idea of cloud computing, back towards this notion of dumb terminals. So now we're seeing more and more aggregation of computing power in the cloud, and we're seeing that the end user devices, whether it be a smartphone and a laptop, are to some degree becoming less and less powerful. So think about something like a netbook. You can buy a Google Chromebook and you can use that, and it's a pretty reasonable computer. But what makes it so powerful? The fact that it's essentially a dumb terminal that's getting access to cloud resources. So this is an interesting vision for the future of computing. Right now we're living in an era where a lot of us still have a fairly powerful computer, whether it's a laptop or a desktop at home. Even our smartphones are pretty powerful. Maybe 10, 20, 30 years in the future, if cloud computing continues to sort of dominate the computing landscape, all we might own at home is essentially a monitor, a dumb terminal, where it just allows us to interact with the cloud, but all of the computation, all of the storage, all of the smarts, all of the computing is actually located in the cloud in some data center somewhere else. Same thing with my smartphone. My smartphone may become less and less of an actual computer, and more just some interaction device that I use to use these cloud services. So this is one vision of the future of computing. There are other people pushing back on this in different directions because there's some problems with cloud computing. But it's interesting to me that, to some degree, this new terminology is really pulling us back in time. And maybe at some point people will look back at the personal computer movement as this weird artifact of computing history, where for this strange period of time, everybody wanted to own a computer. And why would anyone want that anymore? Because now all I have is this terminal, I pay $10 a month for it, it's in my room, and it's faster than your computer today because it's essentially just tied in to this all-powerful cloud.
Computing, also referred to as the cloud, is the delivery of on-demand computing resources, everything from applications to data centers, over the internet on a pay-for-use basis. To get a common understanding of cloud computing, let's start with the U.S. National Institute of Standard and Technology, NIST's, definition of cloud computing. NIST defines cloud computing as a model for enabling convenient, on-demand, network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. Examples of computing resources include networks, servers, storage, applications, and services. This cloud model is composed of 5 essential characteristics, 3 deployment models, and 3 service models. Let's start with understanding the 5 essential characteristics of the cloud, which include on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. On-demand self-service, the first characteristic, means that you get access to cloud resources such as the processing power, storage, and network you need using a simple interface without requiring human interaction with each service provider. The second characteristic, broad network access, means that cloud computing resources can be accessed via the network through standard mechanisms and platforms such as mobile phones, tablets, laptops, and workstations. The third characteristic, resource pooling, is what gives cloud providers economies of scale, which they pass on to their customers, making cloud cost-efficient. Using a multi-tenant model, computing resources are pooled to serve multiple consumers. Cloud resources are dynamically assigned and reassigned according to demand, without customers needing to concern themselves with the physical location of these resources. Rapid elasticity, the fourth characteristic, implies that you can access more resources when you need them and scale back when you don't, because resources are elastically provisioned and released. And the fifth characteristic, measured service, means that you only pay for what you use or reserve as you go. If you're not using resources, you're not paying. Resource usage is monitored, measured, and reported transparently based on utilization. As we see, cloud computing is really about utilizing technology as a service, leveraging remote systems on demand over the open internet, scaling up, scaling back, and paying for what you use. It is a revolution in that it has changed the way the world consumes compute services by making them more cost-efficient while also making organizations more agile in responding to changes in their markets. As I mentioned earlier in this talk, the cloud model is composed of 5 essential characteristics, 3 deployment models, and 3 service models. We just went over the 5 essential characteristics. While we will go into greater depth of the deployment and the service models in the later videos, let me leave you with a brief overview of these models. There are 3 types of cloud deployment models: public, private, and hybrid. Public cloud is when you leverage cloud services over the open internet on hardware owned by the cloud provider, but its usage is shared by other companies. Private cloud means that the cloud infrastructure is provisioned for exclusive use by a single organization. It could run on-premises, or it could be owned, managed, and operated by a service provider. And when you use a mix of both public and private clouds working together seamlessly, that is classified as the hybrid model. Now, let's look at the three service models that are based on the three layers in a computing stack: infrastructure, platform, and applications. These cloud computing models are aptly referred to as infrastructure as a service, IaaS, platform as a service, PaaS, and software as a service, SaaS. In an infrastructure as a service model, you get access to infrastructure and physical computing resources such as servers, networking, storage, and data center space without the need to manage or operate them. In a platform as a service model, you get access to the platform, that is, hardware and software tools, usually those needed to develop and deploy applications to users over the internet. Software as a service is a software licensing and delivery model in which software and applications are centrally hosted and licensed on a subscription basis, and sometimes also referred to as on-demand software. In the next training, we will go over some of the key evolutions that bring us to what cloud computing is today.